SN1 reaction and SN2 reactions. Okay, these are very important reactions. Okay, so we already learned that one alloalkanes will undergo nucleophilic substitutions reactions. Okay, what I say that one? So alloalkanes will undergo nucleophilic substitutions reaction. Why they will undergo nucleophilic substitutions reaction? Because carbon and halogen bond is a polarized bond. Due to the polarization, carbon is getting partially positive charge and halogen atom is getting partially negative charge. Due to the presence of positive charge on the carbon, so another nucleophile will replace to the halogen nucleophile. That's why alloalkanes will undergo nucleophilic substitutions reactions. Okay, alloalkanes will undergo a nucleophilic substitutions reaction. Okay, so in this nucleophilic substitutions are two types. One is the SN1 reaction, second one is the SN2 reaction. Okay, SN1 reaction and SN2 reactions. Let us go by one. SN1 reaction, SN1, okay, dash is equal to 1. It is also known as unimolecular substitutions, okay, nucleophilic, okay, or unimolecular nucleophilic substitutions reactions. Okay, so 1 is represented unimolecular, N is represented nucleophilic, S is represented substitutions reactions. That's why unimolecular nucleophilic substitutions reaction, SN1 reaction is referred as unimolecular nucleophilic substitutions reaction. Okay, similarly SN2 reaction, SN2, 2 is represented, okay, bimolecular, 2 is represents bimolecular nucleophilic substitutions reaction. SN2 means bimolecular nucleophilic substitutions reaction. SN1 means unimolecular nucleophilic substitutions reaction. SN2 means bimolecular nucleophilic substitutions reactions. Okay, next one, why they are calling as a SN1 and SN2 reaction. Let us go by SN1 reactions. SN1 reactions generally follows the tertiary alkyl halides. Okay, normally tertiary alkyl halides will undergo SN1 reaction. Okay, the first class itself we classified the alkyl halides into three categories. 1 degree alkyl halide, that is also called as primary alkyl halide. 2 degree alkyl halide, also called secondary alkyl halide. 3 degree alkyl halides, also called as tertiary alkyl halide. That means halogen attached carbon is attached to 3 carbons. That is called 3 degree alkyl halides. Okay, so the 3 degree alkyl halides or tertiary alkyl halides will undergo the SN1 reactions. Okay, SN1 reactions will undergo tertiary alkyl halides. Okay, yes. Next important point is the rate of SN1 reactions. The rate of SN1 reaction is directly proportional to concentration of alkyl halides only. Okay, the rate of SN1 reaction is directly proportional to concentration of tertiary alkyl halides only, not using base, not the concentration of the base. That means the rate determining step, or the rate of reaction which depends on only one molecular concentration, that reaction is known as unimolecular reaction. Okay, in unimolecular reaction, or if the rate of reaction depends on only concentration of one molecule. Okay, if the rate of reaction is depend on the concentration of only one molecule, that reaction is called SN1 reaction. Yes, the SN1 reaction follows the 2 steps. SN1 reaction follows the 2 steps. Okay, so here this is the I have taken the tertiary alkyl halide, the chlorine attached to this carbon. It is attached to 1, 2, 3 carbon. Therefore, it is a tertiary alkyl halide. Okay. So what I say that one, the SN1 reactions involve the two steps. SN1 reaction involves the two steps. First step is the slow step. First step is slow step in which carbon halogen bond breaking take place. Okay, in which carbon halogen bond breaking takes place to give a carbocation intermediate. To give a carbocation intermediate. This one C. Okay, C plus is a carbocation. Okay. First step is the slow step. In the slow steps, carbon halogen bond breaking takes place, leads to the formation of a carbocation intermediate. Carbocation intermediate. This carbocation is sp2 hybridization and planar geometry. Okay, this carbocation is sp2 hybridization and planar geometry. And the first step is slow step and the rate determining step. Okay, RDS. Okay, in the rate determining step, if only one molecular concentration involved, that reaction is called SN1 reaction. What I say that one? SN1 reactions involve the two steps. In the first step is the slow steps and rate determining step. First step is the slow step and rate determining step. Okay. The first steps, what is happening here? A carbon halogen bond breaking takes place, leads to the formation of a carbocation. This carbocation is sp2 hybridization and planar geometry. Okay, and the first step is also rate determining step. Okay, second step is the fast step. In which the nucleophile will attack to the carbocation. Attack to the carbocation. Okay, as I said that one, this carbocation is a planar geometry. As I said, the carbocation is the planar geometry. Therefore, the nucleophile may be attacked from the front side, may be attacked from the back side. Okay, the nucleophile may be attacked from the front side, may be attacked to the back side. Therefore, if the nucleophile attack to the front side, it will give the one isomer, one enantiomer. Okay, if nucleophile attack to the back side, will give the another enantiomer in the equimolar ratio. Okay, just you learned an equimolar ratio of enantiomeric mixture is called racemic mixture. And equimolar mixture of enantiomers are called racemic mixture. That means in SN1 reaction, racemic mixture is forming if alkyl halide is chiral. Okay, if alkyl halide is chiral. Chiral means what? So if the carbon attached to 4 different groups is called chiral. Okay, it's a very important point. Very important point. What is happening here? In SN1 reactions, we are observing a racemic mixture. What is the racemic mixture? The racemic mixture is an equimolar ratio of 2 enantiomeric mixture. Okay, how we got? This is the attacking of the nucleophile. It may attack from the front side, it may attack from the back side to give 2 equal. This is the probability. Okay, it is having the 50% may attack from the front side, it may attack 50% from the back side to give equimolar ratio of the 2 enantiomeric mixture. That's why in SN1 reactions we will form or we will get a racemic mixture. And this SN1 reaction is more favorable in polar solvent. And the order of the SN1 reaction is tertiary alkyl halide is more than the secondary alcohol than the primary alkyl halide. These points are enough. Okay, these are all very important. Okay, you have to be remember, you must write this mechanism. Okay, most of the times we will ask this SN1 reactions individually or may ask directly SN2 mechanism, or sometimes may ask write the differences between SN1 reaction and SN2 reactions. Okay, once again I will repeat. SN1 reaction will undergo the tertiary alkyl halide. First point is SN1 reaction follows the tertiary alkyl halide. The second point is the rate of reaction is depends on the concentration of only the tertiary alkyl halide. Only the tertiary alkyl halide. Okay. Third point is tertiary alkyl halide. Okay. Third point is the reactions involving the two steps. Okay. First step is the slow step and rate determining step. Okay. In the slow steps, okay, carbon halogen bond breaking takes place, leads to the formation of carbocation. This carbocation is the sp2 hybridization and planar geometry. Planar geometry. In the second step, in the first step, the nucleophile will attack to the carbocation. Since the carbocation intermediate is a planar, nucleophile may be attacked from the front side. Okay, or 50% probability is attacked from the back side. Okay, so due to the attacking of the nucleophile from front side and back side, we are getting the racemic mixture. And SN1 reaction is more favorable in polar solvent. And the order of reaction is tertiary is greater than, secondary is greater than the primary. Okay, this is the SN1 reaction. It is a SN1 reaction. Next one is SN2 reaction. Okay, this one is SN1 reaction. This is the SN2 reaction. Okay, in SN2 reaction is bimolecular nucleophilic substitutions reaction. SN1 is bimolecular nucleophilic substitutions reaction. Okay, this bimolecular nucleophilic substitutions reaction generally primary alkyl halides will undergo SN2 reactions. Okay, so primary alkyl halides will undergo SN2 reactions. Very important. Okay, and in SN2 reaction, the rate is directly proportional to concentration of alkyl halide and the concentration of base. Concentration of alkyl halide and concentration of base. Just as I said that one, the chemical reaction in which the rate of reaction depends on concentration of two molecules. Two molecule is called bimolecular nucleophilic substitutions reactions. Okay, so it's called bimolecular reactions. That means the rate of reaction depends on the concentration of two molecules that are called bimolecular. Since it is undergoing nucleophilic substitutions reactions, therefore it is bimolecular nucleophilic substitutions reaction. Okay, in SN2 reactions, what is happening? The rate is directly proportional to the concentration of alkyl halides and the concentration of the base. Concentration of alkyl halides and concentration of the base. Okay, so in this reaction, simultaneously bond breaking and bond forming take place. Simultaneously bond breaking and bond forming take place. Okay, for example, see this here. Okay, here whenever the nucleophile is approaching from backside of the leaving group. Okay, that means here nucleophile is approaching exactly opposite direction of the leaving group. In this one, nucleophile is approaching exactly opposite direction of the leaving, that is the halogen atom. Okay, in that case carbon halogen bond breaking take place. Okay, carbon and halogen bond breaking take place. Carbon hydroxyl bond forming take place. Okay, so what I am saying that one, when nucleophile is approaching back side of the leaving group, carbon halogen bond breaking take place. Same time carbon hydroxyl bond forming take place. Therefore, this type of mechanism is called concerted mechanism. Concerted mechanism means the mechanism in which simultaneously bond breaking and bond forming take place. That mechanism is called concerted mechanism. Okay, that means there is no intermediate is formed in SN2 reactions. There is no intermediate is formed in SN2 reaction. In SN1 reaction, the intermediate is formed, that is a carbocation. Okay, carbocation intermediate is formed. But in SN2 reaction, there is no reactive intermediate formed. That's why it's called concerted mechanism. Okay. Next point, in SN2 reaction, inversion of the product take place. Inversion of the product take place. Okay. What we learned here? What we learned earlier? Okay. So the configuration of the reactant will changes or reverse. The configuration of the reactant molecule will changes or reverse after the completion of the reaction. That is called inversion of the product take place. Inversion of the product take place. That was first observed by Walden scientist. That was first observed by Walden scientist. Therefore, it is called Walden inversion. That is called Walden inversion. Okay, it's important point. Okay, Walden inversion is observed in SN1 reaction, SN2 reaction. Okay, answer is SN2 reaction. Okay, so inversion of the product take place. Okay, this was called first observed by the Walden. Therefore, it is called Walden inversions. Okay, how it is happening? Inversion take place means how we are taking a umbrella. Okay, just we are holding a umbrella in our hand, moving exactly opposite direction of the wind coming. Okay, wind coming. For example, I am holding the umbrella like this. I am moving this way, and wind is coming from very fast from in front of me. In front of me. What is happening? What will happen? This umbrella will tilt out. Umbrella will tilt out. Okay, this front. Okay, what is this one? That will go backside only, and it will be in my hand. Okay, that will not. Like the same thing here. Whenever the nucleophile is approaching, the molecules, the atoms which are around the carbon moving that side. So configuration of these atoms are changing. The configuration of the atoms are changing after the completion of the reaction. That's why it is called inversion of the product take place. That was observed by Walden. Therefore, it is called a Walden inversion. Walden inversion. Next point is order of reaction. Okay, next point is order of reaction. The SN2 reaction is more in 1 degree alkyl halide than the 2 degree alkyl halide, 3 degree alkyl. Opposite to the SN1 reaction. And this reaction is more favorable in non-polar solvent. Okay, and this reaction is more favorable in non-polar solvent. Okay, this is the difference in the SN2 reaction. This is the SN2 reactions. Okay, what I say that one in SN2 reaction, what we learn in SN2 reaction. Okay, primary alkyl halides will undergo SN2 reaction. Primary alkyl halide will undergo SN2 reaction. The rate is directly proportional to the concentration of alkyl halide and the concentration of the base. Concentration of alkyl halide and the concentration of the base. Okay. In this SN2 reaction, nucleophile is approaching exactly opposite direction of the leaving group. In that time, simultaneously bond breaking, carbon halogen bond breaking take place, and simultaneously bond forming, that is carbon hydroxyl bond forming take place simultaneously. Okay, in this reaction there is no intermediate is forming. This mechanism is called concerted mechanism. Okay, so in the SN2 reaction, inversion of the product will observed. Okay, inversion of the product was observed. It was observed by the first time Walden. Therefore, okay, this inversion is called Walden inversion. This inversion is called Walden inversion. It is the okay, and order of the reaction is 1 degree alkyl halide is more than the 2 degree and 3 degree, and the solvent is non-polar solvent. Okay, please you have to be read. Okay, you have to be study by comparisonly. By comparisonly. Okay, see here. So tertiary alkyl halides will undergo SN1 reaction. Here 1 degree alkyl halides will undergo SN2 reaction. The rate is directly proportional to 2 degree alkyl halide in SN1 reaction. Okay, here the rate is directly proportional to alkyl halide and the base concentration. Okay, here simultaneously it involves the two steps. Okay, here simultaneously bond breaking, bond forming take place. Okay, here first step is slow step, rate determining step. Okay, second step is the fast step. Here there is no stepwise. Okay, these are all concerted mechanism. And if alkyl halide is chiral, the racemic mixture is formed. If alkyl halide is chiral, the racemic mixture is formed. Here, inversion of the product take place. Inversion of the product will take place. It's called Walden inversion. Okay. Here, what is happening? And so nucleophile may be attacked from the front side and back side. 50-50 probability is there. Therefore, it is called a racemic mixture. Racemic mixtures. Okay, like that one. So next one is order of the reaction. The tertiary is greater than, secondary is greater than 1 degree for the SN1 reaction, 1 degree, 2 degree, 3 degree for the SN2 reactions. Okay, and polar solvent is more favorable. Polar solvent is more favorable for the SN1 reaction. Polar solvent, and non-polar solvents are more favorable for the SN2 reaction. These are the differences and similarities between the SN1 reaction and SN2 reaction. Please, you have to be read very carefully, and you have to remember all these points. Either we may write, may ask write only SN1 reaction with mechanism, or SN2 reaction with mechanism, or SN1 and SN2 reactions differences. Okay.